just in brief, what VTT is about. So VTT is a government-owned non-profit company, and our position in R&D chain is between universities and industry. And essentially, this means that the work of our institute or company is a heavily applied research in nature. So we a little bit touch also basic research, and then we do kind of product development, but we don't have our own products. But there's actually quite a bit diversity in this development chain, what we cover at the VTT. And then maybe one important aspect of our work generally and in photonics is that it is heavily focused on integration, and this means that we do prototypes and that require a lot of different functionalities, and also a lot of people with different backgrounds work in the same project, like physicists doing photonics simulation, and engineers doing, for example, electrical designs or mechanical designs, and biochemists doing some development of biorecognition layers, etc. So this is a kind of nature of our work. And so we have about 2,100 employees. Most of the staff have a university degree, and then we are located in several cities across Finland. Headquarters are in Espoo, which is next to Helsinki. My location is in Oulu, that is geographically in the central part of the Finland. And then I picked in these slides a couple of kind of photonics technology domains that we work with. So among of these 2,100 people, about 100 scientists develop photonics. And it is maybe a little difficult to define what is actual photonics project, so that if it's if certain system is especially developed for a certain specific industrial process, and so a lot of work kind of touches photonics, and certain projects they are almost completely photonics. But then here this list then shows this kind of few technology domains. This optical instrumentation, which is about making typically a certain type of sensor units, for example, to monitor industrial processes. Then one topic is silicon photonics and integrated optics. This is essentially making a photonics counterpart on electrical IC circuits. One domain is then printed photonics. I have a slide there. This is maybe a little bit a new term, but is essentially making optics and photonics by printing technologies. And then one domain at VTT is metrology. So we have a national metrology unit at VTT that comprises or use optics quite extensively. And then, okay, the special topic of this session was safety and security. And here the good news that this is almost as such listed in VTT's strategy. So we focus essentially all of our activities in one of these 5 big global challenges. So obviously a lot of environmental aspects regarding climate action and resource sufficiency, and then health well-being is one important topic, and in addition to safety and security, this industrial renewal is important in Western countries, that how we keep our industry competitive. And then starting this photonics domain with the optical instrumentation. So this is essentially a creation of solutions based on measurement science, and here it is optical measurement science based. So essentially how the chain goes at the first there's an idea that is then tested, and then following the chain to make some lab studies, and then VTT's role is then to make these online prototypes. A lot of our technologies use camera-based, are based on cameras, and then also including spectroscopic and calibration functionalities is one of our core expertises. Here you can see then a list of different application areas. You can see that metal mining industry, pharmaceutics, and then defense is one, and in Finland this forest industry is also important industry domain. And then how this prototype creation chain goes. So, and what expertises are needed to make such a prototype. So first, okay, we have this optics part, and then we use some ray tracing or some wave model or rigorous model then to analyze then the system, or for example sensor head, that how optical waves interact with the material. Then we have mechanics designers doing then optometer mechanics, and then how we assemble all the optical components into this system. Electrical engineers do then this design for driver electronics, and then this hardware for user interfaces, and they are working together with the software designers doing this software interfaces. And actually quite significant part of the work is then the data analytics and the algorithm development, and how to make this calibration procedures or include artificial intelligence. And then if the prototypes go to industry, then we need to have also industrial designers, so that the usability is taken into account. And finally, then we have this integration part. And then a couple of examples of kind of merging techniques. So generally speaking, we can say that what has become important in this imaging is spectral expanding of spectral range, or making hyperspectral images, so that we get also this spectral component of it. And then also this time of flight measurements, they have become more and more important topic. And this slide then shows an example of from our recent project, showing that how this time of flight measurement can be used. So we have a fast laser and shoot a laser pulse, and then we have these single photon detectors, and this is a scanner. And then if there's kind of some scattering medium in a light path, so that basically they interfere severely the image, or they block the image formation from the interesting surface plane. But when we then measure basically also the time component, that when photon has reached the detector, then it is actually possible to see behind this scattering medium. In industry, there can be moisture or particles, like in this steel industry, in this picture from steel industry, that is possible to see behind this heavy particle cloud. Or an example picture from a forest, that the leaves blocks that what the vision behind the leaves and what is on the log. These are regular pictures, so you can see essentially leaves, and this is just an example box attached on a log. But when we take a time of flight measurement, so then we can kind of see behind the leaves with this system. And this is now getting more and more interest, is very high frequency cameras. This is an example of our optics design, this omnidirectional lens for infrared wavelength, so that we can see all around us, or get the thermal pictures of what is happening. And this content work on lens design, optics, and then kind of not conventional materials could be used in those lenses. Then switching to other domain, this is then silicon photonics. And as I said, that this is then as a topic, this means that integrating several functionalities on a tiny silicon chip, and kind of making a very compact photonics system, like a fingernail sized system. And at VTT, most of the work is done near Helsinki area, and this relies very heavily on the infrastructure. So we have Micronova cleanroom silicon fab there, and they do a lot of other MEMS work on MEMS development, but this photonics is another important topic in Micronova. And this is kind of a layout about different functionalities or components that this silicon photonic device contains. So a key function the system is created around this silicon waveguides that are usually micrometer range ridges that they guide the light. And then there are different type of oxide materials deposited on silicon and etched away to make these features guiding light. And then several other module phase or intensity modulator structures are incorporated on these chips. And unfortunately, all the functions cannot be created just by using silicons, and therefore we use also hybrid integration technologies then to mount different, for example, semiconductor components on these silicon chips. And then there are a lot of different applications where silicon photonics are used. So you can see here examples in healthcare, and basically all operation of internet relies also quite heavily on silicon photonics. But what comes then to safety and security, this LiDAR laser scanners installed in camera, and when using silicon photonics, then no moving parts are needed when making these scanners. And this shows then this picture shows an example of hybrid integration, so that because silicon is optically non-active material, and then we have developed or put a lot of effort in development of process to integrate these 3-5 compound semiconductor chips, so that the system becomes alive, and there are these light sources and detectors integrated on silicon, and there are a lot of scientific aspects that how to make this coupling robust between silicon waveguides and active components, and also engineering issues that how to make the fabrication yield high and device highly reliable. Then finally going then to third domain what I wanted to include here, and this is our printed intelligence program. So essentially this printed intelligence means making or using printing technologies to make functional systems, not only components or devices, but how to integrate those into real systems. And enabling technologies behind this contains printed electronics, photonics, and advanced manufacturing. And hope this video goes through WebEx, but just to give you an idea how this, what does it mean to use printing to make these photonic components. And this is the process how we fabricate organic photovoltaics. So it's a thin film based device containing electrode layers, hole and electrode injector layers, and then photoactive layers. And these are indeed large area components. And then this video shows how we roll-to-roll print these layers on a web. And here you can see that each of those devices, they are actually solar cells. And quite typically we use this roll format when we make these optical devices or photonic components. And okay, this is a introduction that why what is the purpose of developing printed intelligence. So essentially we have this real world where we are, and then kind of this digital world, and then there's need to be a gate between these two worlds, and those components, there are sensors and actuators, and then printed intelligence essentially complements the technology need at this interface. And we use this printed intelligence in various kind of sensors and environment monitoring systems, and also in automotives. So this essentially shows that how we make these systems from. So we typically have a starting material, then those are kind of tailored then to fabricate components, and then these components are integrated to a system, and using these printing methods. And as VTT, because we are a company on applied research, so what is for us very relevant is to make this technology transfer. And in this printed intelligence, there's now quite or very heavy transfer in printed electronics, and when integrating those inside plastics, so that behind, for example, in car behind dashboard, there's no more electronics, but electronics is integrated in dashboard, and their optics is indeed very relevant to make sensors and these user interfaces. And then as one example device, photonic device is an optical diagnostic sensor. This was developed for cancer testing, and this contained optical sensing layer, then microfluidic layer, cover lid, and then you can check from this web page more information. But we combined surface plasmon enhanced fluorescence and resonance techniques then to make these devices working, and those were used then to detect tumor-associated antibodies and nucleic acid modifications. And this slide then shows that again that how these photonics features were printed. So this is a running web, and we imprinted this plasmonic, or these are dielectric features on a web that were then afterwards coated with gold. But again, here the point was really to use low-cost mass manufacturing methods to make a disposable optofluidic chip. So this was maybe a little bit run through about photonics activities at VTT. But again, so we have about 100 researchers and a lot of different kind of topics in photonics, and then and those technology topics are then applied in several applications. So, but I hope that this presentation gave an overview about all the possibilities that we can offer, and hope you find those interesting. And so, if there are then questions, please visit our website or just send me an email, and I'm then happy to forward that email or then reply personally. So thanks again for following my presentation.
Thank you very much, Jussi, for this great presentation. Let's move to the question session. So we have the first question from Duke. Are you here?
Yes, Professor.
Yeah, so you can ask your question, please.
Okay. Good morning, everyone. First one, thank you for your interesting and inspiring presentation. I am Dick Lê. I'm from Vietnam and PSRS student. I was wondering, as a research professor point of view, what is the challenges to transfer research into industry, and how do you solve these challenges?
Okay, so it is usually a long way then from kind of basic research to industry, and then of course a question in basic research that it has value as such, that not all the findings need to be transferred to industry. But when there are innovations, so then I think that there's good support for the researchers, and then having this good feedback from the either business developers or from the industry, that to really provide feedback for the scientists, that how this new finding can be then utilized, and then what is really the novelty of that. And then I think that then the challenge is maybe that when moving a little bit from further or the direction towards industrialization from the basic research, then it is what I can see that sometimes it's difficult then to find a good funding instrument and resources, so that when the topic is not anymore basic research, and then there are a lot of, and I suppose that most countries have these funding resources and the European Union, but then occasionally then people might need support for that. And then coming to the point that when there's a question with applied research, is that then having really this industrial members participating the same project, and they really then can provide this substantial view that what is relevant, and then and prepare this kind of plans to enter the market. And I see that here maybe the big challenge is still to improve this connection.
Mm-hmm. Okay, thank you.
Okay, thank you. Thank you very much. There will be another question from Mahmoud. Mahmoud, are you here?
Yes, I am here, Professor.
Yeah, okay, so you can ask your question, please.
Okay, I'm Mahmoud Gar from PSRS students. My question is, first, thank you for this interesting presentation. I was wondering about in these job careers of this company, is there a position that combines between the business or project management and also technical work, like, for example, application engineer position in some companies, for example? And what is the general basic qualifications should the job applier has, whether in this field or of work or another field, and so on?
Sorry, was this question to me, Jussi speaking, or to?
I was wondering about a position for example, in this company that combines between the project management or business and so on, or dealing with customers, and also the technical work. So in some companies there is a position, for example, that called application engineer position, and so on, that he has to do these two jobs combined to each other. For example, he may be engineer or researcher, but he is dealing with customers, handling this to the product of this company. And what qualifications that should this job applier has when he apply to this position, if it's already available?
Okay, so yeah, we do have a separate positions for researchers or engineers, and then business development and customer interface. So they are kind of separate different positions, but usually not always, but usually people do have this scientific background originally, and then depending on their kind of personal interest, so that if certain people are more interested in business development or customer interface, so then those people usually kind of over the career, then they shift towards this kind of business development unit, or we're working with customers. It is also possible basically to kind of directly combine, and but then so I'm not saying that it's not possible. This is a kind of typical road that we have this researcher background, but they are kind of combined topics. And then also in some project we have a kind of joint role, so that certain in a single project we need to have this develop this commercial aspect, and then this scientific or engineering technology development aspect, and there kind of there could be then role for this kind of or this dual possibility for a dual role.
Okay,
I'm not sure if I got correctly your question.
Yes, I got it. And any further details, I will email you. Thank you.
Yes, please. Thank you.
Okay, perfect. Thank you very much. So, thank you, Jussi, for all clarifications